Michelle. So today we're going to start talking about unit conversions. Most of you have been doing unit conversions for a really long time without even realizing it. So when you were first learning time, the fact that there are 60 seconds in 1 minute, that's a unit conversion, right? 60 seconds in a minute, 1 minute is 60 seconds. Then you started getting more confident and you might be able to have calculated how many seconds were in 5 minutes. And then you began to understand minutes into hours, hours into days. These are all examples of conversions. Again, in any of your science courses, you may have been introduced to metric conversions, which is where we will begin to review and then moving into more complicated. So you might wonder why you need to do unit conversions for chemistry. Well, they come up all the time, okay, converting simple unit conversions. But the process of unit conversions, which I will often refer to just as train tracks, because that's what they're going to look like when we get them full blown out, is a process that we will use all year. And so while most likely we won't be converting between hamburgers and salaries, because that doesn't really relate to chemistry, the process that you use, this train track process, is so essential. And so we learn this essential skill, this dimensional analysis, these train tracks, on something that isn't super complicated, so that when we use super complicated chemistry, we already have the process down. Okay, so again, some of this may not be too alarming. Some of these are going to be things that you know. And so to start us off, I am curious what couple things that you do know. All right, so there are lots of metric prefixes out there, okay? We do not need to know all of them for this class, okay? So these are the 6 that we are going to use: kilo, hecto, deca, deci, centi, milli. So kilo is at the top because it's the biggest, milli is at the bottom, so these are in order. A silly way to remember the order is King Henry died drinking chocolate milk. So kilo, king; hecto, Henry died; deca, deci, drinking; centi, chocolate; milli, milk. So go with that if you will. But here's a little funny video to get us started.
1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters, 1 decameter is 10 meters, 1 hectometer is 100 meters, 1 kilometer is 1,000 meters, and here is how we remember: 1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters, 1 decimeter's 1/10 of a meter, 100th is a centimeter, 1 millimeter's 1,000th of a meter, and here is how we remember: 1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters, 1,000 kilo, 100 hecto, 10 is decameters, 1/10 deci, 100 centi, 1,000 is millimeters.
Okay, so that was definitely silly, but hopefully made you smile, and maybe it'll get stuck in your head. And if it gets stuck in your head, then you won't forget those prefixes. Now, please keep in mind there are way more metric prefixes out there. These are just the 6 that I need you to know for chemistry. So for fun, we might deal with, giga and nano and whatnot. But these are the ones that you need that will come up in our class. We're not going to be talking about nanometers very much this year. So conversion factors are going to be something that takes you from one unit to another. So anything that are equivalences. So the fact that there are 60 seconds in a minute, 100 centimeters in a meter, 7 days in a week, 100 pennies in $1. These are equivalences, right? We can say that we are going 60 miles in 1 hour, but also we can say in 1 hour we're going 60 miles. So it's really important to understand that unit conversions, that they go both ways, right? And that you can say it either way: 60 seconds in 1 minute, 1 minute is 60 seconds. Okay, so conversion factors, they are used to convert between units, okay? So English units, that's what we're used to in the United States, right? Talking about yards and feet and inches. These are our comfort language. Science is more in the metric world. And so what I've done over here in this table, these little asterisks, it's saying like 1 kilometer is 1,000 meters. 1 kilogram is 1,000 grams. So the little star is representing whatever that base unit would be. Grams, liters, meters, okay, for example. Those are the main ones that we're going to come across for us. And so notice that I switch it over, okay, in terms of the base unit being over here, okay, so like 1 meter is 10 decimeters. I don't like to think in fractions and tiny little numbers. I think it's easier, but lots of people like to say that in 1 centimeter there's 1/100ths of a meter. That's fine. You need to pick what's going to work better for you. This is what works better for me. I don't like dealing with fractions within train tracks and decimals within train tracks. That confuses me. I always like to think, okay, what's bigger? Now, really, really super important, right here in the middle, we have this 1 inch equals 2.54 centimeters. I call that the magic unit converter, okay? It is our magic thing. And the reason that we call this the magic converter is it's what we are going to use to go between English and metric, right? So if you picture a speedometer on a car, they also often have kilometers and miles on the speedometer. That is English and metric in the same place. And so we often are going to convert between the two. And in order to do that, you must use this 1 inch equals 2.54 centimeters. So if you were going from like kilometers to miles, whatever, you would have to go kilometers to meters to centimeters to inches to feet to miles, all the way. Okay, that 1 inch equals 2.54 centimeters. Again, that is our magic friend. We'll get to that later. So let's get going on just basics unit conversions, right? And so you're going to need to set up your units. The way we start these friends, and again, you've probably seen train tracks multiple ways. This is what we're going to use moving forward. Always start with what you are given, okay? So the units that you know. Do you know seconds? Do you know meters? Whatever. So let's say it was, I know that I have 60 seconds. Okay, well, if that's the case, then diagonally, I have to have seconds down there. That's what we are saying. And then what do I want? I want minutes. Okay, so that key part that you are seeing is that those units must cancel on that diagonal. Okay, that is the key part. If you remember nothing else about unit conversions, that's it. You must cancel on the diagonal. Okay, so from there, you're going to plug in your values. So looking at, here's an example of dollars to pennies. It shifted odd. I'm sorry, I'll fix that. But the dollar is going to go on top. Now, notice it says which unit is larger. This is a really important question that you want to ask yourself every time you are setting up a unit conversion, because what is larger always gets the 1. So $1 is 100 pennies. 1 minute is 60 seconds. A minute is bigger than a second. Meters and centimeters. 1 meter is 100 centimeters. Meters are bigger than centimeters. 1 kilometer is 1,000 meters. 1 kilometer is bigger than a meter. Okay, so that what is bigger question is going to be essential as you set these things up. So then the next part is you plug and chug. So anything on top of your train tracks, we're always going to multiply by. Anything on the bottom, you want to hit divided by in front of. So even if you have multiple things on the bottom, you still hit divided by in front of each of those things. So go ahead and pause and take a look. This is kind of me talking it all out in one place. So pause here and take a look. All right, so from there, here's a very basic look at a problem. Okay, so I was told centimeters to millimeters. So when we are working in the metric system, you always want to go to your base. So what I mean by your base is always going to be that second part of the unit. Okay, so that M. So our base here is meters. If it was centigrams to kilograms, your base is grams. So finding that base in the middle. Okay, and what I want you to notice about these two-toned, or three-toned rather, steps is that I am highlighting the fact that those units are canceling on the diagonal. So blue to blue, dark pink to dark pink, left with light pink. Okay, and so making sure that we pay attention to those diagonals in terms of canceling out our units. Okay, so then Let me get rid of these lines. You always start with what you're given, right? That was the first part. And so at the very beginning, I've got those 5.2 centimeters. Then, right, units on the diagonal, down to centimeters, centimeters to meters. Then again, I think to myself, what's bigger, a meter or a centimeter? Okay, a meter is bigger. So it got the 1, right? 1 meter is 100 centimeters. Then we keep going, 1,000 millimeters to 1 meter. Always, always, always cancel on that diagonal. Okay, so centimeters down to centimeters, meters down to meters, right? That is the key thing. And then the other thing is asking yourself what is bigger in each of those conversion factors. Okay, so key things, what is bigger? Always canceling on that diagonal. Okay, so now these problems are starting to get bigger. I would like for you to go ahead and work out this problem and submit an answer. Okay, so hopefully you got through that one okay. Remember to ask questions, and you can talk to the people around you. It's not secret chemistry, right? We are all here and able to talk to each other. All right, now that you've gone through that one, let's give this one a go. Again, reminder, always go to the base. That is your key. Go to that base, cancel on the diagonal, you've got it. Okay, so let's talk about this one, because this one is definitely different in that we've got centimeters and inches involved. Okay, and so what you need to notice when you see that is that centimeters, right, that is in the metric world, and inches is in the English world. And so as soon as you see that, ding, 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 that should set off like stars and fireworks and whatever in your head, that you must use the magic converter. Okay, that 2.5 centimeters equals 1 inch. And so when we set up this problem, like always, we start with what we're given, right? 27.2 centimeters. Create that train track. Diagonally, gotta have the centimeters, right? Always canceling on the diagonal. Centimeters to inches, if I can do that in one step, I plug it in. Then I ask myself that next question. What is bigger, an inch or a centimeter? 1 inch is bigger, and it equals 2.54 centimeters. And so again, making sure that those units, boom, 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 cancel on the diagonal. So 27.2 divided by 2.54, we're looking at 10.7 inches. And that makes sense, right? In our head, we had 27 centimeters. An inch, right, is almost like in that twice-ish range as big. So makes sense that 27 would be about 10.7. All right. So now it's your turn. And again, reminders, cancel on the diagonal, magic converter, okay? Here we've got some serious practice going between that English and metric world. So give that one a go and submit an answer. All right, so this is another tough one here, okay? Again, yards and meters. So notice we've got this magic English and metric thing going on again. Start with what you're given. Cancel on the diagonal. Use your magic yard and, your magic metric to English converter. Talk to each other, talk to me, and submit an answer.